To use the law of cosine, we won't always be able to deal with just A. Notice over here, it's just lowercase a, or it's just capital A. If in the problem they give me different information, I need to be able to manipulate this formula or rewrite this formula in terms of maybe a different letter, maybe capital D or maybe lowercase c, something like that. So I'm going to kind of examine this formula here a little bit, and hopefully you can make this leap with me. If I have an SAS case, that means I'm going to have this side, and this angle for this particular one. And I'm always going to be solving for the side across from the angle, lowercase a. So S, A, S, side, angle, side. Notice in the formula now, it actually amounts to where it goes to the angle. You're going to square both sides on either side of the angle and add them. That's this part. Then you're going to subtract 2 times those sides times the cosine of the angle between them. 2 times those sides times the cosine of the angle between them. That will get you a squared. You'll finish it with a square root. So again, square, if I have SAS, I'm going to square both sides on either side of the angle and add them. And then subtract 2 times both those sides again times the cosine of the angle between them. Seems pretty easy, right? Maybe. Okay, here's what I want you to do. Here's an SAS case. I want you to write down the formula you would use, the law of cosines, with these letters, this new letter. So think about what I just said before. I'll give you a second, see if you can look at that formula and translate it to these new letters. Hit pause if you need to. Okay, we're back. The process was, I'm going to be solving for the side across from the angle, so Q squared. To do that, I square both sides next to the angle and add them. So it would be R squared plus K squared. Next, I'm going to subtract 2 times each one of these again times the cosine of the angle. R, K, cosine Q. It's a theta. I meant Q. There you go. That's the law of cosines written with these new letters. Okay, let's go back and look at the other one then. Side, side, side. For a side, side, side case, you're going to square all 3 sides. I mean, it's side, side, side. You know all 3 sides. So whatever angle I'm looking at, that's my home angle here, A. I'm going to square all 3 sides. I'm going to add the 2 that are on either side of the angle, so C squared plus B squared, and then subtract the one across from it, A squared. B squared plus C squared minus A squared. That's the numerator. So we're going to square all 3 sides, add these 2, subtract this one. I'm sorry if this is my angle I'm looking for. Then the denominator is just 2 times those 2 sides that you added together. 2 times C times B. 2 times B times C. You'll divide those, and then you'll have to take an inverse cosine, right? That's not going to be A. You'll take an inverse cosine as your last step and get what A is. So recap. Square all 3 sides. Add the 2 on either side of the angle. Subtract the other one. Divided by the denominator, 2 times these 2 ones that you added together. 2 times B times C, and then inverse cosine. Think you got it? Think it's pretty easy? Let's try that thing we did again, okay? Hit pause if you need to and try to translate this one. Let's solve for angle M. So I know I'm going to have cosine of M equals, and then I want you to write the formula down involving M, N, and P, lowercase, to figure out what that is. Okay, we're back. If I'm looking for M, I'm going to square these 2 and add them. So N squared plus P squared. Then I'm going to subtract the other one, minus lowercase m squared. All divided by 2, there's that 2 again, times the ones that I added. The ones that I added are always the ones that are down in the denominator, n times p. There's my formula. I'll rip in the numbers, whatever they are, my calculator, take an inverse cosine, and we're dancing. All right, so let's practice this law of cosine. We might have different letters. We've handled that. We have the 2 versions of the formula, which one to use in which case. It's just all about putting it all together now, practicing.